So I named this class Imaging Essentials. It's basically material that no one ever teaches you. You go through a lot of theory in imaging science, but when you actually when it comes down to actually processing images, they don't usually tell you how do you actually do this from a mechanics type of standpoint. And what I hope to do is sort of give you some of that information. A lot of the stuff that I'm going over really isn't in any textbooks. It's one of these things that you sort of just pick up just from working with images. And part of the reason why I use the RIT training prerequisites is because in the past, when we did DIRSIG training, we found that it was very difficult for people to actually learn DIRSIG when not given a system that's already pre-installed and all that. So one of the things that I want to go over are some of the things that some of you, if you decide to use DIRSIG or any other particular type of application, here it's RIT, here it's specifically CIS, is to how to use the CIS systems. And the CIS systems are essentially UNIX systems. And that's actually a very good skill to have, because most people, work with Windows, can do only so much processing. But when you start working with much larger images or larger number of images, it becomes very cumbersome to do things on a Mac or a PC. You have to essentially try to work in parallel high performance, high throughput computing environments, and most of them will be Unix based. So it's hard to get around that. Unix has been around for many, many decades, and it's proven itself as one of the workhorses. So in order for you to be able to say, I know how to handle a Unix system, is worth a lot more than just saying, I know how to use Windows as such. So how many people have gone through the prerequisites? I'll go over it again just to touch base on it, just to express some things that I didn't quite put into it, so that people understand. For those of you people who are not here, can listen to this recording and sort of say, oh, okay, I see why that part is important. So a lot of these things that you have in this document are some of the things that you should get set up on your machine, whether you're a Mac or a PC users. And I actually went through two different installations. So first of all, everybody here has a CIS Unix account, I assume. It used to be that everybody got one, and it wasn't until recently that we realized that that was not the case. So I want to make sure that everybody has that. And I assume, again, probably wrongly, is that most people have logged in to their CIS Unix accounts. And if they have not, we'll try to work on that process right now. So everybody has a laptop, I see that, but let's go over a couple of things. So on the Mac laptop, if you have not already installed it, you want to install something called X11, also known as it's also known as X-Quartz now. So what that will allow you to do is to essentially be able to control the Unix system from your Mac. All right. So there's this concept of X Windows, in which your computer is basically a client. I always mix this up. Is a client that talks to a program running on the Unix system, and that's what's known as an X server. All right. So if you can think of the server software as a program that's running but doesn't have any keyboard or mouse inputs. What your PC or what your Mac and your PC will do is essentially talk to that program and take all the mouse inputs, all the keyboard inputs, and send that off to that system. So there's this client-server model that you have to sort of understand, and we'll go over that in a little more detail as we go through some of the examples. So you should have an X-Quartz. Some of this information might be a little old. This was back in Lion days, but hopefully most of you can install that. Anybody here that has not installed X-Quartz? I know the PC, we'll talk about that in a few minutes, but you guys have have X-Quartz set up and everything? You may have already had to do this in the past if you had to access the Unix system and try to do things. All right. So the one thing that you may want to add to your both hardware and software, if you're dealing with a Unix system, an X Windows system, is a 3-button mouse. Okay, that makes it a lot easier to work in that environment. If you do not have a 3-button mouse, there is this application called Magic Prefs that will allow you to simulate 3-button mice. Okay, because X Windows, when it was developed, assumed that you have a 3-button mouse, and there's a lot of mechanics that will allow you to easily cut and paste information really quickly from one window to another. If you were just using a Mac by itself, you probably won't know about that, but it's good to invest in a 3-button mouse, or at least a mouse where you can emulate 3 buttons using this application called Magic Prefs. All right, and we'll go over some examples of how you would use that. All right. So for the Windows people, all right, I always recommend that people actually go through and install. There's a couple things you can install. You can install Xming. What that does is it sort of gives the Windows an ability to connect to the Unix system and treat it like it was a terminal, all right, and be able to display things to you. The other more favored but somewhat heavy installation is Cygwin, or X-Cygwin in particular. So I don't know if many of you have heard of about that, but that is like the very first. If somebody gives me a Windows system, and I have administrative privileges on it, X-Cygwin is the very first thing I put on there, because what it does is it essentially makes your PC look like a Unix system, and so you don't have this having to deal with DOS or anything like that. It will actually treat it as if it were a Unix system. So a lot of the commands that I'll show you will be the same things that you would apply on the Cygwin on your PC. So if you haven't done that, I would recommend making that installation. It takes a while to install, but it is very helpful, particularly if you want to become more comfortable with Unix. Cygwin is one of those environments that allows you to do that. It's like I said, whenever I get a Windows system, it's the very first thing I install, because I don't have to translate any of the commands that I learn in Unix into the Windows environment. The process is very much the same, and it behaves more or less that way. Okay. So the one thing that we want to go over really quickly is connecting to the Unix machine. So let's start from scratch here. On a PC, I could just I'll start all over from nothing. What you could typically do is do X-Quartz, and you will get a window that pops up. All right, and what you will get is essentially an X window, a terminal. So this is what's known as an X term. And notice that it's kind of hard to see. Now this is where a lot of the mechanics with a 3-button mouse comes in handy. All right, using a little bit of manipulation, hitting the control button, and using the right mouse button, you can click on huge, and that will allow you to basically change the size of that of the X term window. All right, and if we created another X term window, all right, let's create a new one. I don't know why I'm looking at I don't know why I'm looking at that screen. I could look in front of me. All right, I can again create that large, and also control middle mouse button enables you scroll bars. Right, so as you can see, if you want to move up and down, that allows you to do that. And that's why I'm saying that one of the things you want to learn, you want to invest in, is a 3-button mouse. Okay, there's a whole bunch of options here. I'm not going to go through each one of them, but realize that you have the ability to do that. Control left button, okay, more options that are classic with Xterm. And I always tell people to use Xterm because Xterm is present in most Unix systems, all right? So, well, what good is that? Well, what you can do is, if I do an ls, for instance, I can actually select an area. Now, most people say, I want to cut and paste this information. All you really need to do is select it with your left mouse button, and then a middle mouse button. You can paste it directly into a window without having to do cut and paste. So that's one of the options that you have with a 3-button mouse, is you can easily, if you have a word, you can double click on it, and then you don't have to say cut and paste. It just automatically knows that it's in your clipboard, and just do a middle mouse button. Okay, so again, it's one of those things that it's hard for people to sort of verbalize that, because you kind of have to do it in order to see how it works. So when you have a lot of file names, so if you have a directory that you want to go to, all right, so if I say pwd and I want to actually cut this out and paste it somewhere else, you would just paste it, you would just select it, and paste it in that. So I want it to be interactive. If people are having problems doing this, let me know and I can go over it again. I know you probably don't have X windows set, so you just sit back and just listen to what I'm saying. I'm recording this lecture, so you can go back and actually follow through with that. All right. Any questions about that? That's probably one of the. It's a very simple thing once you know it, but if not, unless anybody's shown you how to deal with that, it's kind of a hard thing to understand. So using the 3-button mouse and cutting and pasting is a very helpful process. Now, some Unix commands, pwd, print working directory, all right, tells you where you are on this machine. So this is a machine that, excuse me, this is a machine, this is my laptop right here, and this is where my home directory for this account is. All right. So if I wanted to log into one of the servers, for instance, you want to do an SSH -y. Okay. -y basically allows the machine that you're connecting into to allow what's known as X Windows traffic to go back and forth. All right. What you're doing now is you're going to connect to a machine that is running a program, but you want to control it from your laptop. All right. And this is why, so this is, if I tried to do this with a regular terminal or with PuTTY, it won't work because that doesn't have the protocols associated with that. So let's actually connect to a machine. So if the username that you have is the same on your Mac and your PC, you can just say armstrong.cis.rit.edu. Okay. However, the username for this particular account is DeerSig Training. So what you have to do is you have to prepend this with the username that you have on your Unix account. So rvrpci at armstrong.cis.rit.edu. So that armstrong.cis.rit.edu is what's known as a fully qualified domain name. If you were just within the lab CIS and you just put the Armstrong, rvrpci at Armstrong, it would know to go for that, look for that machine. But if you're logging in from some other place, some other location, you have to give the fully qualified domain name so that it knows how to resolve that information. So let's go ahead and do that. All right. And for those of you who have not logged in initially, it might give you some information that, oh, I don't know this particular system, blah, 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 blah. I didn't set it up that way, but you just want to say yes to it, okay? So I'm going to type in the password I have for that. And there you are. You're at the Unix, you're at the prompt now of the Unix system, okay, Armstrong. Now, a couple of commands that are useful on the Unix system is hostname. Okay, tells you what the name of the Unix system is. You can also do uname -a. That's very helpful, particularly if you're trying to report a problem. A lot of system administrators want as much information as possible in order to debug the situation. And what this gives you is the name of the machine, the version of Linux, okay, and let's see what else, what kind of architecture it is. So it's just one of those commands that you want to always do in order to be able to give as much information about that machine. So before we actually go into more of the Unix side of things, so now we want to have NV or MATLAB, what have you, be controlled by this by my laptop. I can just type NV Classic. Right. And you're basically running NV on Armstrong, but controlling it from your PC or from your Mac, right? So that's that's why having X Windows in the form of either X-Quartz or X-Cygwin is important, because it allows you to operate these types of applications, right? Another application that might be of use to you, which you can actually download on your Mac or PC, but is also available on the Unix system, is GIMP. Okay, so some of you are probably familiar with GIMP, but GIMP is basically an open source version of Photoshop. Okay, I'm not an artist. I don't use GIMP that much. I occasionally use it for visualization, but it is something that you can use to maybe create some material maps. So I won't go into the details of the artistry of changing the images, but be aware that GIMP is available for you if you want to modify any images. You can download your stuff, download GIMP on your machine, but that would require you to basically download other images or any images that you want to work with locally. In this case, if you wanted to just work on an image on the Unix system, you can start up GIMP on Armstrong or Collins or Aldrin or what have you. So that's why, again, you can see that using X Windows, you can actually work on these types of applications. Any questions so far?
So on your screen, like at the prompt, it says like a bash 4.3. When I'm on Armstrong, it says like my name at Armstrong.
Yes. Yes, that is actually a part of what is known as a customization in your when you first log into Unix systems, there is what are known as dot files. Okay, there are two flavors of Unix, just so you're aware of it. There is the C shell, which is an older shell, and there's Bash, which is born again shell. There's actually an even older shell called the Bourne shell. Okay, so those are the three major shells that you need to sort of be aware of if you're working on Unix systems: the Bourne shell, C shell, and then the born again shell, Bash. Bash is the one that's distributed mostly with Linux systems. So I used to teach C shell. But then when Linux became more popular, I switched over to Bash. Now, the different shells have different syntaxes when it comes to actually scripting language. When you have scripting shell scripts. So I will cover mainly the bash example, but realize that there's also C shell there.
Okay, so does that mean mine's C shell?
On which machine?
I'm on Armstrong.
Armstrong.
I was just wondering 'cause mine-
So to find out, what you can actually just do is, trying to remember now how to look that up.
with,
Echo, yeah, $shell. Okay.
All right. It says C shell.
It always the C shell. Okay, that's something that you can change. You can do CHSH. All right. And then you can say bin. So I'm going to do CSH here. All right. Oh, SE shells. CHSH minus L. So those are the different kinds of shells that you can apply. So, okay. I know this is not imaging, but in order for you to do the imaging part, you kind of have to have some ability to manipulate and move around in a Unix system, partly because that's probably the most useful skill, particularly when you start doing scripting. Okay, you need to be very comfortable with moving around in a Unix system to do any sort of large-scale processing, because most of the time you're not going to want a graphical user interface to be clicking a button 1,000 times to do something. So those are the different types of shells. KSH is a corn shell. TCSH is the same as CSH. The only thing that they included in that is actually the ability to do up arrows, the old commands. That's the only difference that I've ever seen between TCSH and CSH. So one thing you'll find is that if you're on C shell, it's very hard to recall the different commands. Like the up arrow doesn't work. So bash is the one that we will be covering most of the time for this process. So you asked about your prompt. Okay. There is a special variable called prompt. Oops. Let's see. Yeah, mine's probably not set up properly, but let's if we do a more on that. Now I'm on bash. Okay. Think of bash RC as a customization file. It's a file where you would put certain paths, okay, to programs, certain preferences, if you will. If you are on on C shell, it's .cshrc. Okay. So as you can see here, just to give you some idea, it'll set up the prompt here. I won't go into any of these in great detail, but just realize that the .cshrc and the .bashrc are two critical components on a Unix system, because this tells you where Unix will look for certain commands, okay? And also settings, environment variables. So in Unix, anything that's in capitals are typically known as environment variables, and they're usually set by the system, or you have to set it yourself. Question?
I haven't been able to run the external window.
You won't be able to unless you installed Xwin or Xmingw. So you just listen for now.
Okay. Can I possibly borrow a laptop, like a Mac? Is it okay for me to be?
You'll have to go to downstairs to borrow that from them. So, okay. But what I would say is install Xmingw. And like I said, I'm recording this. Hopefully, I'm recording it twice, so hopefully one of them will work, and you can follow through. Okay. So where was I? So .bashrc, .cshrc. Those are two files. There's also two other associated files that you may want to keep track of. For C shell, there's a .login file, all right? And for Born, there's a .pro file. What's the difference? The difference is that .login and .pro file are executed once when you first log in. Right. .bashrc and .cshrc are executed whenever you start a new process. Whenever you start a new window, for instance, then those other .bashrc or .cshrc get executed. Right. So that's something that confuses a lot of people. Just realize that one set of them only gets executed the very first time you log in, and the other set gets executed after, or not after, but every time you start a new shell. Okay, a new shell being a window, a new process. Okay, whenever you run a command, it'll create those. It'll run through those .bashrc and .cshrc. Okay. Apologize if you're not a Unix person. You're going, what the heck is he talking about? But just remember that you heard it once in this lecture, so that you can go back and say, okay, I remember him talking about these two dot files. One thing I recommend about modifying your dot files, do it with care. Because if you mess up your dot files, you can put yourself in a situation where you can't execute any commands. Right? So just be very careful. Always make a copy of it before you make any changes. So as an example, if you want to make a backup of the .bashrc, for instance, you would say cp tilde dot bashrc, and you can say tilde dot bashrc dot bak. Okay. So some people will ask, well, what the heck is the tilde? Okay. What is that? What does that represent? The tilde in Unix parlance represents your home your login directory. Okay. If I say echo, that's my working directory. So instead of you having to type in, hello, it's all right. Instead of you having to type in, /CIS/staff/RVRPCI all the time, you can just use the tilde as a shortcut to tell you where your home directory is. Okay, and it also helps in that if you transfer things to other machines may not have /CIS/staff/RVRPCI. By saying put it in a home directory, it's sort of an implied area. Okay, so a tilde is known as a relative path. Okay, and any paths that start with a slash is what's known as an absolute path. Okay, in general, absolute paths are bad. Bad in the sense that it becomes not portable, because what you've done is you've fixed the reference of a particular file or directory to that specific machine. Right? By using relative paths, it's a little easier to be able to show it's a little easier to port a particular script, for instance, so they don't have to assume that there is a specific directory structure. PWD, print working directory. Right. You can also use the command cd to go to a specific directory. That's about as large as I got it. Okay, I was trying to make it bigger, but you guys can see that okay, right? Okay. cd, so let's say I want to go to dirs data dirsig. Right. So if I type pwd, that's where I am. Now, the next two commands I'm going to tell you about probably won't make a lot of sense until you use it a lot. And that is the push D command. All right. And you tell it what directory you want to go to. All right. And what it does is it keeps a stack of all the different directories that you've been to. So if I say push D / user temp, for instance, right, and I type dirs -v, oops. It keeps a history of all the directories that you've been to. Now, suppose I want to quickly jump into dirs data dirsig, for instance. All I have to do is, and that's where I am. Right. So this becomes very handy. A lot of people who first go into Unix don't appreciate this, and what they start doing is they're typing cd to the directories that they go through, not realizing that this command can actually cut down all those commands that you type. If I want to pop off a particular directory, for instance, if I say pop D, it will take off the very top directory and put you in the next directory. So there you are. So push D and pop D, very useful. Becomes also very important when you start scripting out a set of runs that you want to send over to the cluster. Because what you want to do is you want to be able to go into certain directories really efficiently, really quickly by push D and pop D. Right. So I introduce this right away. Most people go, I don't really appreciate it until later down the road when they say, oh yeah, instead of me having to type CD, CD all the time, the name, push D and pop D are one of those commands that come in very, very handy. So let's think of what's other commands. Date, okay. Units. All right. So there's a lot of silly things that you can do here. This is something I used to teach, but now with the internet, it's fairly easy. So if you want to say, I don't know, furlongs to feet, right, gives you the conversion. Again, keep in mind this existed before the internet was around. Right. So the other thing that's helpful to know is that you actually have a calculator in front of you. Most people don't know that, but there's a command called BC, and you want to give the option -L, and you can do whatever math that you want to do here. Okay, 2 + 2. Okay, that still works. And we'll actually come back to this later because one of the things that is lacking in most of Unix is the ability to do floating point math, and we will actually use BC as a quote-unquote hack to do some floating point math through scripting. So again, quit. Let's actually go back to give you a couple of other commands. If you want to, the special characters that you need to know on Unix, one of them is called Control D. Okay. Control D simulates an end of file. So if you want to do something that requires you to, there's an example. If I say cat and I want to put input from keyboard.txt, okay, the quick brown fox jumps over the lazy dog. Control D. So Unix has this concept of files. Everything's a file. Your keyboard is a file, all right? Your screen is a file. And what we just did here is we said concatenate the keyboard into a new file. We can look at input keyboard.txt, and there's that information. Right. Yes?
Where's the file? Couldn't find it. When I had the command
Cat?
the cat input from keyboard, it says that permission denied.
Type of PWD. Okay, these examples are good. Where are you right now?
Bar.
Huh?
I'm in a bar 10.
Okay, and it would let you. So what you want to do is you want to go back to your home directory. So if you just type CD, that always brings you to your home directory. Okay, now give that command again. So those are permission denied. If you ever get a permission denied error, it usually means that you're in a location where you're not supposed to be writing to it. Okay, there's protections.
If I type PW right now, it's my user account.
That's right, because when you type CD, CD without any arguments will always bring you to your home directory.
Okay, so let me try the
You have to make sure you got the greater than. Okay? Right. So what is that greater than? Well, that greater than is actually what's known as a redirection operator. So if I say ls, for instance, or let's make it even simpler. Let's type date. Right. If I just type date, it'll send that information to the screen. But if I want to save it into a file, I can say type date, and then I can say date.txt. Right. To look at files, you can say more. And there it is. Okay. So let's say we wanted to figure out how many characters are in this, or how many lines and characters. You can say WC, which is a word count, date.txt. And it's telling you here there's 1 line, 6 words, 29 characters. If I said date, WC, all right. What is it doing? What it's doing is it's taking the output of date and piping it into a command called WC. Okay. What is WC? WC is a command that works mainly with text files that allows you to look at the statistics of a file. How many lines, how many characters, how many words, right? WC is one of those, it doesn't seem like a very useful thing initially, but you realize later that it's actually very powerful because you can start trying to figure out whether or not you have a file that is properly formatted by just looking at the number of characters, number of words, number of lines, right? So WC. I also introduced here the command called man. Okay, man is the unfortunate help of Unix. You can go on the internet and look a lot of these commands up, but sometimes you have to look at the man page that's specific to your machine, because sometimes what you may catch on the internet may not be specific to your particular quote-unquote flavor of Unix. Unix, being an open source system, has a lot of variants. Okay, there's a lot of different types of Unix. There's a lot of different types of Linux systems, and unfortunately, that results in different variants. Okay, you'll hear the different types of Linux, such as Debian, Fedora, Ubuntu. Okay, just realize that those are all Unix systems, but each of them has their own little flavor. Okay, in much the same way that you can say that there's British English, American English. Okay, and I don't know what the other English would be, but you can start breaking down American English into Southern English and Northern English. So there's a lot of variance in that, and Unix is being a language has the same type of advantage or disadvantage. So let's go back to just showing you certain commands: pwd, cd. Help me out here. What other commands that you guys want to know?
What if we want to delete those files?
Ah, good. So because Unix was written by computer scientists, they don't really they like terseness. So if I want to remove first of all ls_date.txt, okay, ls-l allows you to give ls-l date.txt. Well, I'm here. I'll get to your question, but this gives you number of bytes of that file. And if we did the wc on date.txt, we will see that 29 characters matches that. To remove that file, you can say date.txt. Right. If you are paranoid, however, you might want to say rm-i date.txt. Because what it'll do is it'll say, are you sure you want to remove it? And I don't know why it keeps doing this, but it should be displaying the file name there, and you would say yes. Okay. And in a later class, we'll talk about regular expressions. Okay, some of you have probably seen something like ls star. Okay, ls. T star, okay. And we'll talk about that a little more. Other questions? Those are the kinds of questions I like to, sometimes I'm asking you guys these questions because I've been working in Unix so much that some of these things are sort of second nature for me, so I don't think about the questions. So those are the kinds of questions I want all of you to try to ask me so that you can get the answer right now. You can rename files. So cal. So what I'm going to do now is I'm going to redirect it and say January txt. Okay. So if I want to rename that, I can say mv January.txt to January.txt. And the reason I make this example is that Unix, I want to emphasize that Unix is case sensitive. Okay. Unlike a Mac or a PC, Unix in its native form is case sensitive. Right? Those are two totally different files. Right? So you have to be very aware of that if you're trying to work with files and all of a sudden it says I can't find a file. Just be aware if that's the case. Now, if you're running Cygwin on a PC, you will be limited by the fact that a PC is not case sensitive. So you have to be very careful of this process. But on a Unix system, these are the things that you want to be able to understand that these are two different files. Let's see. A couple other commands. We talked about the more command, but let me see if I could find a file that's pretty big. Oh. All right. So if you have a file that's pretty big, you use the more command, and you use the space bar to allow you to move forward. You can also type the B command to go back. Right. And if you're done, you can type the Q command. Right. So that's something that's useful with more. The other command for looking at a file is cat, but the problem with that is that there is no control. Okay, it just goes off and spits out the information, which is not very useful. That's why the more command is one that you will be typing a lot. Okay, so spacing to, and then if you're searching for a specific word, you could do the slash. Okay, and I don't know what word. Okay, so it found one, and then to find it in reverse, you give the question mark. Any questions with that? A couple other commands. Head. Very useful if you're just want a quick number of lines at the beginning of a file. And tail will give you the very end. Oops. Oh yeah, the very end of the file. Again, you may say I don't know when I'll ever use that, but trust me, there'll come a time when you say, oh yeah, I can use that. Also understand that you actually have options for head. If I do a man on head, it'll tell you different options, like how many lines. The default is 10 lines, but you can actually tell it to just print out one line. So if I say head minus n1 of tutor.vi, it gives me the first one. And that's actually very useful if you have a text file, for instance, or let's put it this way, you have 1,000 text files with a header on it, and you want to remove that header before you send it into your program. This is what you would use to do that. Okay. You would use the head command to well, a combination of head and tail to remove headers and leave the numbers for you to work with. Editing. I always tell people to bite the bullet and learn VI, Vim, as you would say. Partly because there's some things in VI that allow you to, that becomes useful later once you've learned them. All right. And it's kind of hard to say what that is right now without going into details, but try to, if you can, spend some time trying to work with VI. Sorry about that. And there's actually this tutorial that's in my account. You can say tilde RVRPCI, oops, tilde RVRPCI slash tutor.vi. Oh, sorry about that. That's not good. Anyway, I'll send you the command. But if you're not comfortable with VI or want to start with something smaller, there's called the Nano. Here's the Nano editor. Okay, at the very least, that gives you something that you can don't have to go through a lot of memorization of keystrokes and commands. It's pretty straightforward. All right, so Nano is a editor that you can put in there. See, I'm already typing VI commands here. Control X. Yes, and then so let's see what else. What other little goodies do we have that you should know in Unix? You know how to edit files. You know how to rename files. transferring files from your laptop to the Unix machine, or to the Armstrong, for instance, is using what's known as the SCP, which is the what's that? How to close Nano? I don't know. Control X. Okay. I don't use Nano, as you can tell. But this is if you're on the Unix system. No, I wouldn't hold it against you if you did Nano for a while. But if you want to get more advanced, I would use VI, just to illustrate a couple of things that we'll go over later in a later class. Sometimes it helps to know which command is being used. So if I say which NV, for instance, this will tell you where those commands are coming from. Okay. This is particularly useful because there is an actual command in Unix called test. And this problem has come up several times in my career, where someone who's creating a program calls it test. And they kept wondering, it's like, why isn't my program running? Why isn't my program running? It turns out they were actually running the test command in Unix rather than the command that they compiled. So it was just an unfortunate situation because their path, if I say echo $path, for instance, what that represents is all the directories that Unix will look through in order to find a command. Whenever you type a command, it will say, it will go to that directory first, user lib 64qt33 bin, go to the next one, the next one, the next one, until it finds a match. Right? If it says command not found, then you didn't have the proper path in there. So a common thing that people run into, they type a command and it says command not found, it's because it doesn't exist in that path variable. Okay? So somehow you have to modify your path variable in order that exists. Right? It's either that or you type the entire location of that command. Right? So in this case, if NV was not in your path, you would have to type /usr/local/bin/NV. Right? But again, one of the reasons I show people the which command is the more insidious situation where you happen to be executing another command when in reality, or you're thinking you're executing a command that you own, when in reality it's actually executing another command that's actually part of the Unix system. And test is just an unfortunate name to give to both the Unix command and a command that you do. So, like, this happened when somebody was learning C, for instance, and they did the hello world, they did print hello world, and they were going crazy. It's like, whoa, I can't get it to work. In fact, let's actually do that just so you know, you guys see how a compilation, and this is sort of off the cuff. So let's go nano, and it's called hello. It's called test.c. You know, you can just sit back and enjoy the view. Int main void. This is just, I'm just doing this so I can see if I remember how to print f hello world. Okay. Control X. Test.c. So we have a C program here, very simple. Right? How do I actually get it to compile? I would say gcc test.c. If I don't give it any arguments, it'll always default to a file called a.out. Right? If I try to run it, it says command not found. Okay, why is that? It says command not found because the current working directory is not in the path. So in order to actually run this, you would say .a.out. There you go. Why? Dot represents the current working directory. And if you look at your path, nowhere in there is the current working directory specified. If I did the following now, where I said, okay, I'm going to mess this up because it's been a while. Path. So first of all, let's do that. A.out, command not found. Let's look at the path. Okay, doesn't appear to be there, but let's actually include it there. So I would say path is equal to $path, colon, and then period. Colon is used to delimit the different directories. The period tells it to look for the command in the current working directory. So if now I say echo $path, we see at the very end there, right there, that we have the period. Now I can say a.out. Okay? So that is how you would modify your .cshrc or .profile in order to be able to, in order to search for the UNIX command and then execute that command. So gcc -o test.c. So this is the command, the unfortunate command that that person who was having problems happened to give, right? And now if we give the command test, look at that. Nothing's working. All right. If I say .test, now it does. So that illustrates a 3 days worth of a person banging their head on a wall because they couldn't. They said, you know, this has to work. Why it's not working? And they didn't take the time to just say, you know, this is weird. I have to ask somebody what's going on. And that's one of the things that you want to do with Unix is that if you are banging your head against the wall for more than, I'd say, an hour, maybe 2 hours, look for help, because I've made all the mistakes. And a lot of the people here who are comfortable with Unix have made all the mistakes, and they can tell you right away that, oh yeah, it's because you did blah, 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 blah. Right? And this is stuff, this is not a reflection of your intelligence or anything like that. It's just a reflection of your lack of experience in Unix. And that's something that you don't naturally get. So what I just showed you here will hopefully save you, hours of grief with Unix. So let's see, what else have we got here?
Started to talk about the transferring files to your own computer.
Yes, thank you. So there's another command called file that will tell you the what type of executable it is. Right? File test.c. Okay. The reason I do this is that just to illustrate the fact that if you're on one machine, if you're on one machine and you want to run a program on it, you sometimes have to recompile. And in this case, I think we will have to recompile. So let's say SCP, which stands for secure copy, and RVRPCI. RVRPCI at armstrong.cis.rit.edu and colon, and then you can say test.c to here, and it'll ask you for a password. All right, so that got copied over to my laptop, and just for grins, I'm also going to copy a.out. So we have test.c and a.out. Now, we can't run a.out because it was compiled on a totally different architecture. Right? That's why you're seeing that. We can actually do a file a.out, and it does recognize it, but it knows that it can't run it. So we have to actually compile this now. So we can, oh, I might not be able to compile it because I don't have the, I might not have the environment properly set up here. I'll try it anyway. That's long. Now you know why you want to use the Unix system as much as possible. Anyway, what other stupid Unix tricks? I call all these like stupid Unix tricks because they're useful, but they're stupid because it's not something that's actually finished. So a.out. And we can say a file. Okay, so you can see it's a different type of architecture. Right. Let's see. There was a thought that I had. Copying files, moving files. We did that. Renaming files. I don't want to go too deep into some of the more advanced stuff, but protections. All right, so let's look at this really quickly. This section here represents the user protections. In other words, the user, you, can read, write, or execute a specific file. All right. The next three sets here, R dash dash, means that the group, right, can read this file only, and the next three is at other. So you have three levels of protection on a Unix system. One is the user, the second is the group, and the last is other. If you type groups in your command or on your machine on the Unix system, it will tell you what groups you belong to. And those groups are represented by this set in the middle here. All right. So let's say I wanted to remove the ability to delete this file or edit this file. I would give the following command, chmod. And this is where some people will type in that numbers, but I like to be more explicit with the symbols. So I would say U minus W test.c. Okay, so if you look at this, there's a W right there. But after we give this command, ls-l test.c, we've removed that option. So that now if we say vi, or if we say nano test.c, okay, and try to modify that, let's say error writing, permission denied. That's because we removed the ability to delete that file. Right. So let's get out of here. No. All right. Now, you can set this to also be chmod, and you can say g equals rwx. Okay, just to illustrate that you can make those changes. Now the question that most people should have is that, well, what does x represent? What does that mean? Okay, x, the meaning of x will depend on a couple of things. One, if it's a file, it'll think, if you give it an x protection, it will think that it's a shell script and will allow it to be executed. Right? Or if it's a directory, that will allow other users to actually go into it. If you don't have an X in a directory, for instance, you cannot go into that directory. So that basically helps you from keeps people outside of being able to go to a directory. So let's create a little shell script just to illustrate that. So vi testme.bash. And what you would typically see is something like bin bash, and in this case, let's just say echo I am here, and the date. All right. Okay. Testme.bash. Let's look at it. All right. So what I've done is just created a very simple shell script. And if I said testme.bash, we'll say permission denied. Why? Because testme.bash does not have execute privileges. In order for this to work, you would have to say chmod and then u plus x testme.bash. Now I can say testme.bash and it will run. So those are little things that you could try to read all this in a Unix book, but most Unix books I've read are very, very well, it takes them a while to get to the point. Unless you know what you're looking for. And that's also the thing, is that if you know what you're looking for, it's usually easy, but if you don't, you could be floundering around. And often you won't face that issue until you've got a problem to solve. So there's a lot of problems that I've had to solve in the past, which made me go back and look for those solutions. So one of the things that I want all of you to think about is think about what research you're doing right now, and probably at the very end or close to the end, bring up the problems that you have so that we can try to solve it using some of the techniques that we'll go over in the other two lectures. So we didn't really do anything with images yet, but one of the things, that there's GIMP on there. All right. There's also a in most Unix system is a image magic. Okay, so I don't know if I have any files here. Do I have any images? I'm an imaging scientist without any images. That's pretty sad. But we can create one. Actually, that's one of the exercises we'll do next class, is actually create images using the text editor. All right. And that'll hopefully illustrate a couple of things that about how images are made. Let's see if I. Okay, this is do not try this at home, but a find command is one of your. I won't go over it now, but find command is one of the most powerful commands that you'll ever learn in Unix. And just if I don't go over that, remind me to do that. What I'm doing right now is I'm going through and looking for any files that are JPEG files, and I found a couple, and they're Lena. So the one command that a lot of people may or may not have known, and this is something that I think somebody in imaging should know, is that there's a display command, and I could say /testing Lena 100.jpg. There you go. Who knew? You don't need MATLAB, you don't need NV, you don't need any of those specialized programs. You don't need GIMP. ImageMagick is installed in most Linux systems, and we'll cover a lot more commands with ImageMagick. But realize that all you have to give is a display command on a Unix system, and you'll have that. And that's why when some of you who have PCs, you want to install all of Cygwin, because Cygwin has ImageMagick as part of the distribution. Okay. Let's see. I have to cut out at 3:30, but this is hopefully you guys learned something in all my ramblings here. As you can see, I've prepared for lecture really well. Other things that you guys should believe you should want to know with Unix, because next class we'll actually use some of those things that I went over to actually work with an image format that I think every imaging scientist should know. And whenever I poll most people, they have never heard of it, and that is the NetPBM format. Anybody? NetPBM format. Okay. To me, that's sort of a travesty that an imaging scientists don't know what NetPBM is. And it's one of the simplest formats that is out there, and it's probably one of the more flexible ones that people should know about. So we'll cover that next class. I'll give a lecture on what it is, what it means, and how all the other formats that you hear about, JPEG, PNG, what have you, can be derived from, most of it can be derived from NetPBM. Let's see, what else did we cover? Basically, I just wanted to go through a lot of Unixy type things. So ls to test.txt, we know what that means, as opposed to ls wc or test.txt, which should give you an error. Right. So again, I just want to re-emphasize, this is a redirection. Greater than is a redirection. Anything that goes out to the screen can be brought over to a file. Right. Anything that you can also then pipe information to a command, and the reason you get permission denied here is because this is not a command. Okay. If I say ls wc, we have that. You can also pipe have multiple pipes. In fact, let me see if I can remember how to do this. Nah, I'm gonna mess it up. But you can have multiple pipes, WC, LS, WC, and then pipe that through, I don't know, let's cut out the first column or the second column. That didn't work.
I'm sure how to close the file.
What's that?
How to close the file.
Which file?
Um, yeah, mine starts right in the LS.
Oh,
Yes.
you probably didn't. You probably missed that part. Control D
That's no.
doesn't work. What do you mean? Which one are you having problems with?
This LS dash
Let me see that again.
File.
Oh, because you're still running the display command. So let me cover that. So I said display. Okay, this will actually be a good segue. You can say history. It'll give you everything that you've done.
Oh yeah, it's finished.
What's that?
I didn't know that it opened some image. So
Yes, it opened the image. So you can actually, so if I want to recall 107, okay, there you go. And what happens here is that display takes over the command. It blocks you from doing anything. What you can do is actually hit Control Z and type BG. And what that'll do is allow that process to keep going. Okay, so you can do other things with this. You know, you can do image info and still be able to like do other commands here. Okay. Now, what's interesting with history also is that if you don't know the number, you can always say exclamation point and then the first few characters, and it will recall that. Now, sometimes you don't want to recall that information because you probably don't want it to actually do it. You can say exclamation point DI:P. What that does is it calls the command but doesn't execute it. Okay. If you type history, you'll see that it's the last command. So if I say something like DISP:P, and then I hit that again, so exclamation point is to execute the last command, and it'll do that. Again, a lot of things I'm showing you. If you never use the Unix system, it's not going to sink in. But as you get familiar with it, hopefully you'll remember that. Oh yeah, I remember hearing that you can do these little shortcuts to do these silly little things, and that's one of the things that you probably want to learn, particularly if you're typing in a lot of commands. So what I did here is just send one to the background. So the nice thing about Unix is that you can start processes, send it off to the background, right? And you can monitor them, okay, by using the jobs command, and it shows you what's running. So if you've got a process that takes a while to run, you can send it back to the background, and it'll run. And then if you want to go back to it, you can say foreground %2, for instance, and you'll get access back to that particular process. Right? You can get control back by doing that there. So let's see. What else do we have here? Any other questions? Again, some of you did get a chance to install your Cygwin, but Xcygwin, please do that. For those of you who didn't have a 3-button mouse, you may want to do that. And also download Magic Prefs if you do have a 3-button, or if you don't have a 3-button mouse, but want to emulate a 3-button mouse. So for those of you who came in late, the thing that I had up here is Magic Prefs. For those of you who have a Mac and you want to emulate a 3-button mouse, download that, and you can try to set up a 3-button mouse using either a double tap or triple tap. I can't remember. There's several ways of doing that, but it's sort of a key element for working with Unix from a Mac with only one button. So you can use some of the gestures associated with that. What else do you guys want to learn? You don't know what you don't know, right? But part of it is, I think the Unix part is important. I think once you get that foundation, we'll go over images, creation of images. Let's see, what else did I have on there? Some of the stuff that I put on there was more for my benefit. Octave, PDL, those are basically open source versions of IDL and MATLAB. So I just put that there as a placeholders. One of the things that we'll cover also is using makefiles. Okay, makefiles is typically used for programs, but makefiles is actually useful when you have a process that is dependent on the result of another process, because one of the things that you don't want to do is that if your process sort of dies, you don't want to have to start from the beginning, right? And sometimes a makefile will help you alleviate having to rerun different results in your workflow, right? And we showed you a little bit about scripting here, how that make a simple one, but we'll elaborate on that using some of the other tools that we'll cover, particularly ImageMagick. Okay, ImageMagick is open source and is well suited for manipulating images. A lot of people use it more for artistic modifications, similar with GIMP, but you can use it for scientific images just as easily. So, all right, let's call it a day, and also bring specific questions that you guys have in your research. You know, if there's something that you say, if you feel like you have a workflow and you think there's an easier way of doing things, there probably is, okay? And you can bring that up next class to ask, you know, how would I do this? I have like 1,000 images. How do I actually do the process of applying a convolution or something like that? Or convolutions with different size kernels. Those are the kind of things that most of you will run into, is doing a lot of sensitivity analyses of modifying a particular parameter and then trying to get it to run. I'm going to talk to Paul Mezzanini at the Research Computing and see if they're in a state where you guys can get accounts there so that you can actually at least make some baby programs that will utilize the cluster. Because as I mentioned before, when you start doing all these permutations of images versus kernels versus whatever parameter, you can easily see that that becomes an exponential number of runs. And if you want to run that on a single PC, you could be here for years, easily years. And being able to run it on a cluster will save you time, you know, weeks. But would have taken months can be done in a couple of days. And there's a lot of your peers have experienced that with some of the things that they're doing with simulations. So I want you to at least understand how to format your problems in such a way that you can use the cluster over in the research cluster. Okay? All right, we'll see you in a couple of days, and don't hesitate to email me with questions, and I'll cover those in the next lecture. Yep. Mm-hmm.
So should I use instead of segment? Can I use other program like
Xming or
no, it's MOBA Xterm, I think.
yes, you can use that. The reason let me just stop this recording. How do I stop?